Welcome back to another video. So this is a video really quick after the last one, and let's have a look at the thing I've been doing lately. So I've been looking for the registers, and I actually found one, and yeah, it was really hard because we don't have all the layers we need. So last time we talked about the address lines, and when you have the address lines, you can find out where the registers are, or at least the address decoders, such that you can get an read or write strobe leading up to the register. So yes, I've been doing that. So I've been mapping out all the address lines, as you can see. So very likely all the decoder is located along these lines. And from those decoders there will be strobes for read and write, and those strobes are activated using the control signals. So when you have the correct address and the control signal says read or write, you get a read or write strobe. And the second thing I want to show you now is data bus signals. So here you can see the data bus. So now we have all the internal system bus signals. I'm sorry, I think I have this one a bit high. I'm also really sorry about the background noise in the last video. I had this fantasy that it's going to be really nice to have some ambience to the recording, but what I didn't take into account was that people were going back from lunch in this really large, it's like an open space in the whole building, in the middle of the building. It has really nice reverberance. They were taking the elevator like madman and slamming doors and walking and talking and so. So I did the last VIC 20 video, VIC 20, the VIC chip video. I actually did record at the same spot in that location. This time it was just too much noise. So back to this, we have the data lines, and the reason and the way I show that's just looking at data signals, and to find out what is what, it's really hard for me now to see what is what here. So what I did is that I just used logic and look like, okay, if you're going to write to port A, which is over here, we need data over to port A. So D0 will then go to PA0 and D1 will go to PA1. So that's really easy. So I just look for stuff that did actually do that. So, and then I found the data signals or the data bus. So that's how I traced out the data bus. And I also checked that at port B, we actually had the D0 going in on port B. So that's good. And you can also see it goes in here. We'll come back to that at the end of the video. Now that we have data, we have address, and we have control. Now let's find the decoders. Because when you have the decoders, you know where the registers are and the name of the register. So we can go in on this page, for example, we can see for information about the CA 6526, we can see all the numbers of registers. Here, OA will be time of day and such. So we can start naming things. So I started looking at the address decoders, and well, you can see it's tapping of signals here, but it's really hard to actually make out anything. And so I had an idea what it could be, but no, it seems to be tapping off something here at the end of the register. Well, and you have power up here. Seems to be just a big power fill in the middle here. So I think maybe the signals goes down here, or the gate internals of the gate is going in here. I'm not sure. But we are getting lucky, because if you go to the end of this side of the dieshot, you have the same register, or the same decoder circuit over here, and this place is a bit more open. So I started tracing out, and I had to do some guesswork under the metal layer here. So let's have a look. Diffusion. All this diffusion is going other places than just here, but you have to make a choice where you want to draw it, because yeah, you have to stop somewhere. So I cut out its holes, and I also drew poly. Poly is a lot more easier because you can see it everywhere. So let's see what's going on here. Yeah, well, we can see we have power ground here. So you always look for power first, and then we have VCC up here and here. Kids are screaming, but you like background noise, don't you? It gives a little bit of ambience. And then let's see. So this is pull-up. I'm not sure what's going on here, because I can see what's going on here. Probably it's just an amplification of the pull-up. So probably here there should be this output of this gate is in here, by the way. It probably goes in here just to amplify this pull-up thing here. So I won't go into that, but the way this works, I will draw it really crudely and delete it later. So the circuit looks a bit like this. You have the pull-up to VCC, and then you have a wired OR configuration. So you have one transistor here, goes down to ground. I believe you have 5 of those. Let's see what they are connected to. So this will be the output. You see you have another one on this side, which is very, very equal. We'll come back to that shortly. And what's what here? Let's bring in the address. Okay, here's the address. And we see that the address line A0 is here. So you can actually say this is A0. Actually, one of these will be high, then the output will be low. So basically you have an OR gate, NOR gate, sorry. So this is the equation for that matter. And we can use De Morgan here. Actually, I forgot one little bit here. Let's say it's read. I'm actually not sure. So I'm going to just say R here. Either it's read or write, I don't know. So if you have this combination of address lines and the read, this one will be high. That means all of these transistors are off, and you will get a high here, out here. So let's bring in the control. And there you can see control, actually. So I think this is a read. I'm not sure yet. Or this is a write. So you can see this one can actually control if it's a read or this is a write. Address coder is like mirrored. Like you have the same address, both of them. But the difference is that you have one has a read and the other one has a write. So basically what it's doing, it's creating a read and a write. So what kind of number is this? Well, if you look at it, it looks like 1, 0, 1, 1. 1, 0, 1, 1. Let's have a look at the calculator. 1, 1, 1, 0, 1. And that's a D. So let's have a look. What's on register D? It's the ICR. Yeah. Now I'm not sure if this is actually it's 1101. It could be 0010 because I haven't looked so closely at the address inputs. But for now, let's try make sense. See if this leads up to the actual ICR. And one thing we can look at flag. Actually, I did look at flag because it's a pin. It's just an input pin, but I ended up finding IRQ, so let's have a look at that now. So let's see where those read and write strobes, they are called strobes, go. So whenever one of these two fires, or goes high for that matter, they will actually read or write to that register. So here you can see it taps off these lines. So this means the register is over here. And interestingly, when I bring in the data bus, you can see read or write will then bring data into this data bus. So from the register. So we'll look at that later when we're able to map out this register here. So let's see. Yeah, it stops over here. So the register must be here then. So I have made a little note that this is the ICR register. So yeah, cool. Now I found the first register in this chip. So really happy about that. And as I said, I wanted to make sure that this actually makes sense. And so let's go backwards. We are reverse engineering here. So let's follow IRQ, which is this large transistor here, driven by this one. So we go into the gate of that one and follow it around. Let's see. Oh, really? You want to pass there? Okay, yeah, let's pass there. And it ends up here. So this looks like an output of the register for some reason. So how does the IRQ work? Well, for IRQ signal, it will be high if there's an interrupt event. It doesn't say which event it is, it just puts the IRQ high. And that's really helpful for us now, because then this will be an output of the IRQ. So it will sit at the edge of the register there. And then the CPU has to go in and read this address, and then it will get back all this data. So interestingly, this is bit number 7. So let's see if it's actually bit number 7 that we are looking at here. So, well, we have the data is tapped off on the locations like this, and I can't really see what's going on there, but we see it's on the edge, so it must be the last one here. So let's follow it, see if it leads up to bit number 7. Let's see. Let's be a bit careful here. Oh yeah, it's the outer edge. Outer edge is very promising. Let's see where it goes. Oh yeah, here it goes. And there we have D7. Great, now we can be confident. We have found the first register and we can name it ICR. Interrupt Control Register and Status. So I'm really happy about that.